Okay, so now we're going to do an incomplete dominance problem. Incomplete dominance is when neither allele is completely dominant over the other one. So we get an intermediate or a mixture of the two alleles. I always think of it as having two paint cans. If I take a paint can of red and a paint can of white and I pour them on the ground, where the two come together, I'm going to have pink. And so it's an intermediate step. And so we're going to do an example with pea flowers, or snapdragons, I should say, which are a form of a pea, the member of the Fabaceae family of plants. And so we have some possibilities. We have the possibility of the genotype of big R, big R. So both alleles are going to give the red paint can. So this would be a red snapdragon. Then we have the opposite, which would be the genotype in which we have two paint cans that are white. They're capital letters because they're both still paint cans. But when we mix a red paint can with a white paint can, we get pink. And so some organisms show this intermediate form in their phenotypes. And so in our examples that we're going to do in class, we're going to do a red snapdragon crossed with a pink snapdragon. So we have red crossed with pink. So remember that step one is going to be to write the genotypes of the parents. Remember that the mom is always given first. And so the genotype of the mom flower or the female flower is going to be big R, big R. And the genotype of the male flower is going to be big R, W, because they have both a red allele and a white allele that mixes together to make pink. So step two is to complete the Punnett square. And so here we're going to put the mom on the side, remember. So she's going to have the 100% that she's going to pass on the big R allele. And then male flower is going to pass on the red allele and the white allele. So then we fill in the Punnett square. So those are all the possibilities for the female contributing to the offspring. So we have 4 possible offspring from the cross between our red female flower and our pink male flower. Now the third step is to write all the possible genotypes from this cross. So if I start in this square and I write that genotype, big R, and I look, I notice that I have another one. So 2 out of the 4 possible offspring would have the genotype big R, big R. Then I'm going to look at the ones I haven't done yet, and here I have big RW, and I'm going to look to see if any of the possibilities are the same, and it is. This one's the same, so then I have 2 RW. And step 4 is to write all the possible phenotypes. So I know that these 2 possible offspring are going to be red, and I know that these 2 offspring are going to be white. Pink. Sorry, I'm not paying attention. So if I was a plant connoisseur and I thought that I was getting plants that I expected, I could ask the person I got it from, will the cross between a red and pink, if I buy them, will they give me a white flower? And so hopefully the florist is smart enough to say, no, there's no possibility that occur, because it's going to be 50% possibility red and 50% pink. 2 out of 4.